Grade 10, Grade 11, Physical Sciences. Welcome to today's lesson. As you can see on the screen, today we'll be talking about determining the percentage composition of a compound. We know that a compound is made up of two or more elements. For example, in our case here, we have H2SO4, which makes a compound called sulfuric acid. So the purpose of this lesson is to find or to determine the percentage or the percent of each element which forms sulfuric acid. In other words, we are going to determine the percentage of hydrogen, sulfur, and also oxygen. And when we add the percentage of these three elements, they must give us 100%. So how do we determine the percentage of elements which forms part of H2SO4? This is how we start. We calculate the molar mass of each element. In one of the lessons that I've done, I was teaching you about how to calculate the molar mass. So you can visit that lesson to find more, but I'm going to do it again in this lesson. So for me to find the molar mass of each element, I'm going to make use of periodic table. I'll make use of a periodic table. Here it is. What do I do with this periodic table? For example, if I want to determine the molar mass of hydrogen, I will check here on the periodic table and locate hydrogen. It is, and find the atomic mass of periodic or of a hydrogen. And then in this case, the mass number of hydrogen is 1. But if you come and check here on the compound, we do not have 1 hydrogen. We have 2 of them. This means that the mass number of hydrogen, the one that I've shown you on the periodic table, it must be multiplied by 2. As you can see, I've indicated it here. 1, which is the mass number, multiplied by 2, because we have 2 hydrogen. This will give us 2 gram per mole. This is the mass, or this is the molar mass of hydrogen. Then we move to the second one. We calculate the molar mass of sulfur. So again, we'll make use of the periodic table. Locate sulfur, here it is. And then the mass number is 32. And then if you check, sulfur here is 1 only. It means that we are going to use that 32 as it is. The molar mass of sulfur is 32 grams per mole. Then we move to oxygen. How many oxygen? 4 of them. So what is the mass number of oxygen? Is 16. So what will happen to this 16? We will multiply it by 4 because we have 4 oxygen there. And then the results will be 64 grams per mole. So here we have managed to calculate the molar mass of each element. What do we do next? We then find or calculate the molar mass of H2SO4, which is the compound. We now calculate the molar mass of the compound. In this case is H2SO4. How do we calculate the molar mass of a compound? Molar mass of H2SO4 equals to, open bracket, the bigger one. Then for H2 is 1 times 2. Remember, we have done this already somewhere here. Yes, we already have this information here. 1 over 2 is the same as this one. I just have to put it here, 1 over 2. When you move to the next element, you put plus. The next element is sulfur, and we already have the molar mass of a sulfur, which is 32. We just have to put it here, plus. Again, we already have the information regarding the molar mass of oxygen, 4 multiplied by 16. And then when we work out all this, we get 98 grams per mole. Now, with these molar masses of the elements and also of the compound, what do? The next step is to find the percentage of each element. We then find the percentage of each element. How do we do this? You can start by any element. In this case, I'm starting with hydrogen. Hydrogen, 2, which is the molar mass of an element, divided by molar mass of a compound. Molar mass of an element, in this case, is 2, divided by molar mass of a compound, which is 98. Then you multiply by 100%. If you do this, you'll get 2%. You can confirm this by using your calculator. This is the percentage of hydrogen. Then we move to the next element. In this case is sulfur. The molar mass of sulfur is 32 divided by the molar mass of sulfuric acid, which is 98. Then we multiply by 100%. This will give us 33%, as you can see on the screen. Then the next step will be finding the percentage of oxygen. Again, you'll divide the molar mass of element by the molar mass of the compound. Multiply by 100%. This will give us 65%. If you add all this percentage that you calculated, they must give you 100%. So I want you to try this one. Calculate the percentage that each element contributes to the overall mass of hydrogen chloride, which is HCl.